Whatever. Which we don't necessarily, we don't fit in the system. So that's the balance I wanted to confirm, because I think the main way is to get those response, but so I figured out for myself and then this side, but I realized that either we need to switch it and then we should need to put the device on mails or we have the numbers, which means that if I was compatibility with the past, so the draft is now one select. You have one compatibility node, which forces it to be 60 objects. But then you can extend it, but then only if you know, we know that you only want of your another node should be objects.
I'm just checking if that shows in the other one. Sure. It's really on this screen. And this
Hello, everybody. Welcome to the 6th Low Working Group meeting. If this is not where you want to be, this is the time to leave. We won't take it personally. So we have, before we start, we have Dominique is going to take minutes for us. I don't see him. Maybe here somewhere. But we do need Jabber scribes. Anybody willing to serve as Jabber scribe or Jabber relayer, whatever? Anybody willing to bring questions in from Jabber? Anybody know what Jabber is? Okay. I'll go for Jabber. It's okay. But don't have them. Okay. Yeah. Well.
So hello everyone. I'm Samita and Gabriel is with me. This is the 6th Low session, as we mentioned before. Online agenda and Jabber Room, Mitico and Etherpad are all noted on the first slide. We already announced in the mailing list that our secretary, Jen Sudier, has moved on to other responsibilities. I just wanted to announce it. We wanted to announce it again, and we wanted to thank him for his service. So going forward, we have a very tight schedule today in the agenda, and if you look at the agenda and see if you have any comments, so we'll try to switch, but we will start with the 6 Low PAN and the ISG review presentation, and then we'll follow up with other 2 updates on the ND related. Then we'll go for NFC. IPv6 over NFC. Then we will go for the routing header lifetime use cases, and we will end with the fragmentation design team report. So, any comments on the agenda? Pascal, are you happy with your time allocation? Okay. Yeah, I think that because everything is on this one deck you sent us, so your last presentation and information sharing to the 6-law working group, that will be moved up. Yeah, just spend 5 minutes. Okay. So and also at the end, we have Benjamin from HC, from plug tests. I think they are doing some plug tests. They were here for IETF hackathon, and they want to talk about their test cases and future plans. We have
So Vita, Carsten here, the agenda has a slot for me presenting the minimal fragment. I did a presentation yesterday in Elwig. Don't think we have to repeat that. So maybe you can give the entire slot to Thomas.
Okay, I thought we...
Oh, where's Thomas? Thomas is Pascal Reuter.
So there's a section devoted to the design team, the fragmentation design team.
Yes.
So Thomas is going to start that off, and then you're going to have the sort, one section for your graph. Pascal is going to have a little section for it's a consolidated set of slides for that.
Yes, all I wanted to propose is that we don't have to do the veterinary assembly buffers again, because we did that.
Show of hands, because it was designed team for 6-law. So if most of everybody here has seen it, then we can skip that part. But you can do that during your section and just gauge if there's interest. If not, we can cut it short. But
fine.
I'll leave it up to you.
Yeah, maybe you can just, not everybody was in Elwig, so if you can give a 5 minutes overview, that would be good. Consolidated slides and then. Okay, so the draft status for working group since last IETF. We have RFC 6775 update, that is ISG reviewed and the comments were addressed. Backbone router is preparing for working group last call. 6-law APND work is in progress. And BLE mesh, Carles send the updated status about the implementation and the progress of the draft to the mailing list. So that document also is in progress. Draft IETF 6-law use cases will be presented today. It's in progress. 6-law deadline time, they are also in progress and probably ready for the last call. I'm not sure, but they are in progress. There will be presentation on that. And draft 6-law PLC, it's still an individual draft. He has updated version number 3 from the comment from IETF 100 last time, and also IEEE PLC standard. He also says that he has discussed it with ITU TSG 15Q15, and he will have a newer version in the next IETF timeframe. And 6-law fragmentation design team update will be provided by the design team lead, Thomas Watney. We have several members of the team. The names are on the screen. They actually made a good progress, came to conclusion in isolating the implementation issues and some simple fix that Carsten has proposed on the implementation side to avoid fragmentation, packet loss, and delays. and overall protocol solution for higher reliability when you are using fragmentation over the network end-to-end. That is proposed in a solution that will be, that Pascal is going to discuss. Okay, so that's brings to the last page, and we are going to discuss some of the items that are probably miscellaneous, but things are also important. One of the things is that Karsten mentioned to the chairs offline, and we also discussed in today's IoT Directorates meeting that a lot of the time we do develop protocols over here, and we don't see much deployment out there. And also we don't have a good 6-law information page, wiki, to provide details on the implementation or what exactly we are doing, how it can be applicable. So Karsten used to maintain a good 6LoWPAN page, but that has now expired or taken away. We are looking for volunteers to help us out on updating some of the materials. So, Karsten, do you want to say anything on the work?
Yeah, Cosmo, this actually came up in a class when students who had already seen pages like cbo.io and cohab.technology asked me, is there something like this for 6LoW? And there is nothing like this for 6LoW. There used to be the old 6lowpan.net, but maybe something that's really just a landing page with lots of useful links to implementations, tools, and reference documents would be useful. So if you don't know cbo.io or cohab.technology, just go there and have a look. It's pretty low effort to run such a site. We put this on GitHub. So actually when people have updates, they usually just send a pull request and you can just merge that and then you are done. I think it's relatively easy for us to do that. But it, of course, will require a little bit of work to collect the initial content of that site.
Okay, so if there is any volunteer, please contact the chairs and Karsten. Thank you, Karsten. And for the sake of the time, I'll just go quickly for the second and third bullet point. There was a recent T2RG side meeting where there was a research presentation which showed that there are some issues, performance issues due to the protocol interaction in the wireless networks. And they expect that there might be some impact in 6LoWPAN stack protocol performance, although nothing has been identified that we know of. Laura Mary Finney, I don't know whether she's here. Okay, so she is the contact for that research, and if you are more interested and if you like to provide some more information to the mailing list, Laura, please do. And so we will follow up from there. So the last point is 6LoW plug test cases, and it's included in the slide. Primary contact is Alan Ribon, and they currently support IEEE 2.15.4, NFC, and VTLE in plan, and they are interested in participate in IETF hackathon and plug test. So with that, we will start with the next presentation. Pascal. Yeah.
So I have about half an hour to discuss 4 drafts, which are really saying a single story. And the story starts with the update of the 6LoWPAN neighbor discovery protocol. The goal of the whole story put together is to enable a large building or large factory to have small devices which just support 6LoWPAN, 6LoWPAN ND, and that's it. And those devices would be able to move seamlessly inside the whole factory, join different route over DODAG or whatever shape that takes, and maintain their routings without having to remember their IP address, etc. So that's what we are trying to achieve across all those. I don't know what's happening.
Yeah, I'm trying to.
Yes. So basically, there are a number of elements that need to be put in place in order to enable the whole story that I'm talking about. It looks simple, but actually it takes a lot of effort to get there because you have to have a number of those route over networks to appear as a single network for the moving device. The device has to be able to move without renumbering, without reforming a security association, etc. And it has to be, it has to have a very simple host side implementation. So just the radios, radio security, whatever, 6LoWPAN, and doesn't need to know anything about the routing that takes place in the network. And that's pretty much what we end up doing with this series of documents.
Sorry, we are having a little bit of trouble maximizing focus. Yeah, try with.
You need to send that to the other screen.
Okay, so now you're saying that I have to put it in the other screen. It's working here, but they cannot see that.
The last time I said it.
That was the PowerPoint slide, and this is the PDF. That's the difference. It was. It was before, but not now. If you want to switch to your. That's really. The other one doesn't show, right, either.
So, you know what, why don't I start my story? Because I just have half an hour. So, I'm going to skip the backbone router because nothing much changed there. I'm going to talk mostly about the ISG review of the RFC 6775 update. And I have a few questions and few validation that need to be made by the working group because a number of things have changed. And that also applies to the address protection draft. There are a number of things which have changed, and I want to make sure that the working group is happy with what's going on.
So try. Sorry about that. then this may not work then. Okay, good. Thank you. But this thing may not work.
So there is quite a bit of text at the beginning that I encourage you to read, but we won't have time to go through all this today. It gives you some background about why we've been doing this and what we are doing. Lovely. So that's it, start here, that's okay. I'm skipping the previous slides, you won't be surprised. So there is a group of 3 documents at 6LoWPAN, which are the update itself, which tells you about the changes we're making to 6LoWPAN ND. Then the address protection thing, which is basically savvy protection for 6LoWPAN. So how do you protect an address against somebody wanting to steal your address through ND? And how do you prevent somebody sending packets sourcing with an address which belongs to you? And the last draft is the backbone router, which is, as I mentioned earlier, if you want to build this big network with multiple route over DODAGs or whatever that is, and have an Ethernet or some type of high-speed network interconnect those routers, those LBRs, what operation do you do if you have classical ND on the backbone? So it's really the interaction of a classical ND on the backbone and the 6LoWPAN ND / route over protocol that you may have on the 6LoWPAN network. There is a 4th document that I will present at the end, which is how that works with REPL. So at the end of the day, when you take those 4 documents together, you effectively can build this network, which spans the big factory with thousands and thousands of devices, and they all reach the nearest gateway, the nearest LBR. They form a DODAG there, and they're all interconnected into a single subnet, so they can move smoothly, seamlessly inside that network without reforming addresses or reforming keys, etc. And this doesn't work. Oh, which address did you take the... So sometimes you have to take the battery out for that. I don't have a laser. So, bad day. So let's see now, let's go through the changes that we made since the ISG review started. So the first thing was not really a consequence of the ISG review itself, but was the consequence of the work which is happening with the address protection thing. Something we discussed very early in the 6LoWPAN ND that was not there for a while and now it's there. It's the capability to have a length which is not 2. And that is not backward compatible with the previous 6LoWPAN ND. So if you are in a world where you have to coexist with backward compatibility to older devices, then this cannot be used, right? There is text which says that's only when you know, and we'll see that now we can really know whether we are in a backward compatible or not world. If you are in a world where you have only upgraded devices, then you can use a length which is longer than 2. And the reason why we need a length that is longer than 2 is that this field, which is now called the registration ownership verifier, and that's another consequence of the ISG review, will be longer than 64 bits because we put a cryptographic token. And the way that we thought we could inherit from CGI to build the 64-bit token is actually very expensive on the client side. And we thought that some clients could not afford to do that. And if they can't spend all the cycles doing the cryptographic things that you find in CGI, then the only alternate was to make this field bigger. And so that's why we actually provisioned for a length which is like larger than 2. So if there is any problem with this and any problem with this and the rest that I'm going to present, please raise your hand, because this is a big change. Next slide, please. So the second thing which appeared here is also a consequence of this, which happened during the ISG review, but was not an ISG review command. It's the problem of telling the route over world whether this is also a router or which will handle its routability later, or participate into REPL, for instance, or if this device is a plain leaf, meaning that it doesn't know anything about the router, doesn't know anything about anything else. It just wants the infrastructure, the routers to do their job and make sure that his packets will come back to him. And the original idea was that the REPL devices would set the bit and that the leaf would not. So this spec would have been transparent. But the discussion tended to say, hey, there are many REPL devices out there which don't set the bit. So the backward compatibility will be very hard. But the plain 6LoWPAN in the router world don't exist. So this is a flag day for them. Let them all set the R bit to on. Okay, so the R bit now is a host setting which says, oh, I'm a host, I'm not participating to any routing, I don't know what routing there is, I don't want to know, I'm setting the bit. If there is a router, please do everything I need to be done because I won't do it myself. You see? So basically a 6LoWPAN node which does not participate to the router has to set the bit. Next slide, please. So this has been there for a long, long time. This is the TID. So the TID is a sequence counter. And this is how we can do this seamless roaming. As you know, when a device moves from a place to another place, the infrastructure has to figure out of the two information, which is the most recent. And there are two classical ways for doing that. You have a timestamp or you have a sequence counter. And the timestamp, when you have a very constrained space to put your timestamp, is a bad idea. We don't know the resolution we need, etc. Some things can move very fast, some things can move very slow. So what's your unit? What's the space? So the sequence counter is much easier to deal with, but it has to be provided by the moving device. So that's why it's one of those two information that 6LoWPAN is now providing to the routing protocol, e.g. REPL. So this is this TID. So that was one of the biggest things we wanted to do with this update. Next slide, please. So the registration lifetime is also, well, no, it's not much change. It's, no. No, actually, this one was not changed, right? I don't think so. It was there, right? So next slide, please. Yeah, so this is the most important change. The change is that we don't necessarily use an UI64 as the identifier of the device anymore. Actually, if you think about what you want to express, you don't want to say who is the owner with a unique ID or something. You want something to enable to correlate a second registration for the same address. So as to see if the second registration for the same address is coming from the same guy. That doesn't mean that the token that you're using to verify that has to be a unique ID. If it's a unique ID, one of the ISG commands that they had is that you have privacy issues around that, because now you're leaking the UI64 of the device. There are privacy concerns with that. So one of the ISG reviews I got is even asking whether we should take the path of deprecating the use of UI64 for this purpose. Okay. Anyway, the new term insists on what this exactly is. It is not an identifier of the source. There is new text which says don't do it for that. Don't do it for correlating two registrations which have the same identifier, because this is a different thing. The scope of this field is registering one address. Okay, that's the scope of it. That's its value. A same device can use different rover fields for different registration. Don't think that by looking at all the registration with the same rover field, you'll get everything from the same guy. It is not the meaning at all. So that's why the name has changed. It is used to verify that the second registration for the same address is about the same guy registering the same address, not two different guys. That's what it's for. So we have a lot of new text to clarify that. And the name has changed actually 2 times during the review. Next slide, please. So I have some, well, it's going to be very quick. I have some limited flows there. We can go quickly through them. What's important here, that's the bootstrap of a network, is that now we have musted a 6CIO option, which is an option that Kirsten has actually standardized some time ago. We must the presence of a 6CIO in the arrays. Actually, that must is inherited from Kirsten's draft, but and that's how we know that the sender of the array supports this update. We have new flags in there, It's an option with flags. So we have new flags, which tells the support for this draft. And that's how we know for sure that we can use it or not with this router. And there is also a flag which tells whether the 6 LBR supports the draft, because this has consequences to not only the arrow option, but also to the DARDAC exchange with the 6 LBR. Next slide. So initially in the draft, like before the ISG review, there were 2 ways of getting there. And one of the review comments was, hey, it's too complicated. We need one way. I think that was Adrian. So now we have one way, and we discussed with Karsten and Blau, and we ended up saying the 6CIO is the right way. Here I'm giving more details on what goes into registration. So the arrow option is called now an extended arrow, just to discuss it easier. The source of the registration is always a link local. And the address that you're registering now is in target of DNS. You know, there is target field in the ICMP header. That's where the registered address goes. And that's good because when you see on the right, the registration goes between the 6 LBR and the 6 BBR. The source of that packet cannot be the 6 LoWPAN node at the end of the network. It has to be the guy who sends the packet. So to do this proxy registration by the 6 LBR, I'm sorry I don't have a laser, but you see between the 6 LBR and the 6 BBR, there is this NS E arrow. I'm missing an E here. You see that the source of the packet is the 6 LBR, but the target is the 6 LoWPAN node, right? So that clarifies why we had to change the source, because in the original 6 LoWPAN ND, the source address of the NS was what was registered. Now it's the target, okay? But we know from the 6CIO whether we are in the compatible world or not, so we know what to do. And yes, optionally in the NS arrow, you can see the APND options that come there. Next slide, please. And there is the flowback. So after a timeout on the backbone, the address is unique. So that's the 6 backbone router says NA arrow to the 6 LBR. And that flows back as previously. Nothing very surprising. That's pretty much what we do. Next slide. So I will give you more about the what time? How much?
We have 20 minutes.
Yes, so I have like 4 or 5 slides, one per review. So I think it's worth going through at least my summary of the review, because these were all great reviews, very detailed, a lot of comments. So I'm just giving you a short summary of the main items. So Tim Sean for Interia told us that's Tim who told us that using UI64 at all was probably a bad idea. So we have it for backward compatibility. The group never discussed about completely deprecating that. So we may, and that's something to be discussed here, have a plan to deprecate it. There was a lot of text from him, and I guess with Dave as well, we discussed the text on privacy address and how we can clarify what we do about privacy. Yes, Tim asked for, because you remember we had this document about requirements. We used to have a requirements draft. This requirements is dead now. Well, it's timed out, but I copied it mostly in appendix so people would know what we serve. And actually, it was not clear what this document serves versus what's left to be served by further document, or what is already served by different documents. So I made this table with the state of the art of what I know, which document do what, so we can figure out of the long list of requirements that we knew which one are served by which document. Also required us to add the glossary, and part of the further review moved the glossary from appendix all the way up to terminology. Last but not least, there was this important comment by Tim, and that's something to think about, and please come to the mic or to the mailing list about this. Since we are holding a registry of addresses in the 6LR and then in the 6 LBR, there might be a day where this registry goes out of space. It could be an attack. And there is text in the security section about protecting oneself from attacks. And the question there was like, is there a minimum number of addresses that we should be storing for every device? What's that value? What's the minimum? What is a good value? And the question is not really for us, but for 6 man. So maybe there is an interesting work to be asked from 6man about, when you have a device which has to store information about, a router has to store information about the devices, how much space does it need per device, at least? And then it says I cannot support this amount of device or something like that. You have to do something about creating more routers. Okay, so that was an interesting question by Tim. The draft doesn't have an answer, but, well. Sorry? I didn't slide on you as well, but.
I have a comment on that, but if you have it on a later slide, I'll wait until you get onto that one.
I hope it's on yours as well, but maybe because it was there, I didn't do it again. We'll see. Otherwise, please come to the mic anyway. So then we had Jürgen and Chris. And so, yes, some terms were found to be offensive, like legacy, talking about the original RFC 6775. So we changed that to RFC 6775 only, meaning supports the RFC 6775, but not this. That was the first change of the name. So if you look intermediate draft, the UI 64 field, which was the unique ID field, was renamed to registration unique ID to really refer to the fact that the scope of this information is the registration itself, not the whole world, and it cannot be used for inferring things in between registrations. And the new option came in, new requirement set on the operation and management. So there is a new, it has requirements, maybe nothing matching them, but at least we have those requirements stated now. That was Jürgen. Next slide, please. Dave. Now, please feel free. It's just a short summary. I mean, I just picked some highlights. Maybe I was wrong picking those, so just correct me. So that's this version 14 where the error flag came in. It was not Dave's comment. Like I said, it was the parallel discussion with the role people telling me, hey, the error flag should not be in a role spec. Saying put it on, it should be in the 6-low spec to put it on so that the role device, the backward compatibility with REPL still works. A lot of rewarding on the rover field, explaining what it is, what its scope is, etc. And yes, Dave, I have your comments stated here as well. What is the minimum number of addresses?
So Dave Taylor. My question is partly for Eric, who's sitting back here. So question. So this is in response to your point, Pascal, about saying, well, maybe this is a job for 6man. In the normal neighbor discovery route, the router has some cache that it can't forward without an entry in there, but it can evict entries in the cache and repopulate them with new ones just with performance issues. And so you can evict stuff in the cache whenever you want, as long as you're willing to do the extra exchange to repopulate them. My understanding is you can't do that for the things that are registered with ARO. So my question is really, is there any other case in 6man where you can't evict a particular thing from the cache, or is this really a 6-low specific problem and the answer belongs here? I'm wondering maybe it's not appropriate to throw it over to 6man unless there's some case that comes up outside the scope of 6-low.
You're asking a technical or procedural question?
I'm asking the technical question because if there's no other case other than the 6-low point about ARO, then it's a 6-low problem, not a 6man problem.
Yeah, so I mean, this thing only shows up in this specification and 6775. There's I tried a couple of years back to get 6man to say, well, this could actually apply more broadly across other links, and that didn't go very far. So it's sufficient to have it in here.
Okay, thank you for that. So I believe that you cannot throw this over the wall to 6man. It should be addressed in this working group, potentially with review from them, but it's your problem because you created it. So we, right? Created, so we should solve it in this working group and not try to throw it over there. And so for what is the minimum, I argued in my email, well, obviously the answer isn't 0, okay? And I think most people would agree that the answer isn't 1, because that means you can't use both local and global addresses or something like that. I think many people will also argue that the answer can't be 2, because that would say that you can't use privacy addresses, non-privacy addresses. And so certainly the minimum is greater than or equal to 2, but is there a higher number it ought to be? And this is the group that I think is the one that actually needs to make a recommendation because we created the problem. They should review it or whatever, but I claim the number better be at least 2, maybe higher.
Well,
And of course, 6-man would say infinite, right? But because we created the problem, right? So you got to come up with some number that we think is reasonable.
well, we can come up with a number which is reasonable for our case because we know a number of things.
Yeah.
But
yeah.
then when we want to port this document for a larger purpose like 6-man, they will have to revise this number. Probably they want something much higher. Because in here, what we have is we have a link local, at least one, which is derived from the UI64. That's used for making the registration, the registration. We have a global address or ULA address, which is derived from the UI64. And that's used for the join process. And, well, at the end of the join process. And mostly we have one which is based on the short address and the PAN ID, that's 36 low PAN original 15.4. So on 15.4, you end up with 3 addresses at least, right?
On a normal host, meaning one that just follows RFCs on a regular
That has
Ethernet
no
or Wi-Fi,
privacy,
the number is approximately 10.
Right. So
And
if
so you get that from one link local, maybe one ULA, and one regular global address. And for privacy addresses, you have the address of the day for the last 7 days.
Yeah.
And so you add those together, and your minimum bound for normal behavior would be about 10. And that's assuming that you don't have multiple subnet prefixes per link. So if you get into HomeNet cases, we might have multiple subnets per link, then just multiply that by the number that you want to allow for. But it's on the order of tens or tens, not ones.
Yes, and that's back to your question. Do we serve this group, in which case 3 is a good minimum? I'm not saying do only 3, right? But it's a minimum. For 6LoWPAN only things, 3 is good. For going anywhere outside of this constrained network where you compress the IP address based on the MAC address, blah, then you need a lot more. And so should we spec for just our minimal need, or should we spec for something broader?
You can, Suresh Krishnan, you can must for the 3 and should for something larger if you want. Like that would be one way to deal with it. I'm here for a completely different reason. So like, do you want to go through this first, or do you want me to like, there's something that's been bugging me and I have to say it, like, and then kind of like think about it in the working group as well. So that's the TID processing in the draft, the transaction ID.
TID, oh yes, TID, yes.
And so I'm a bit uncomfortable with the text there currently because it says like this is like the same as Ripple for being consistent, but I'm copying and pasting the text. Okay, but okay, so
it's really true. It's what happened. Yes, correct.
Okay, so it's one or the other. So either like we say this is the algorithm we use and just put it in there, or we say we use the Ripple algorithm, because the issue is like if the Ripple thing gets changed at some point in the future, we're going to have an inconsistency from this document. It says like, hey, we want to do what Ripple does and also do this. So I've thought about this quite a bit, like ever since like 12 hit, like I've been thinking about this like right from my AD eval time. But I just wanted to like the working group to make a considered decision on how to go about this, because I really don't like it. Okay, I just don't want to push it on the working group, but I would either like a straight reference saying go look at 6550, like, you know, take it from there, or just put this algorithm, copy and paste, but don't say it's from 6550. Say this is the algorithm and be done with it. So that's 80 hat off comment.
Yes, I leave that to the chairs because this discussion happened once already, and this is a result of we changed from pointing to what we have. So I do what you asked me to do.
We have changed to some text, and then you went back to...
Initially, it was a pointer to RFC 6550. Right? And I took the inline text of 6550 instead, saying it is inline text of 6550. And now what Suresh is telling us is either I come back to what I was before, or I remove the fact that it's a reference. I just keep the copied text, but I don't say it's copied from 6550.
Right, that's fine with me. So keep the text. Don't say it's from 6550. Like, you know, IETF, we provide outgoing rights for every RFC, so we can take freely from any IETF document and copy and paste, right? Like, because like you're kind of putting in the expectation of being in sync, because I don't know why it needs to be in sync with Ripple, right? That's like personally may or may not be an implementation thing, but you're putting in like a false expectation that it'll be in sync with, because Ripple might change independently. That's really my concern. I don't mind whichever way it's done, but
Well, even if Ripple changes, we don't reference Ripple by name. We reference RFC 6550, right? So it's that one. If Ripple
If
changes,
6550 is obsoleted, right? At some point, people are going to say, "Hey, like, what do I do?" Right?
it will.
Because-
And if we want this device, to follow it, we'll have to revise this as well. Otherwise, we'll be mismatched. I mean, whatever we put there, I mean, there's no solution to the fact that the implementation will have to change.
I understand, but if like the reason for linking with Ripple is you're expecting the implementations to be shared
That's the
somewhere,
goal.
right?
Yes, certainly.
If that's the thinking, then you're on the same router, then I would just say like a straight reference. Otherwise, I'll just say copy and paste and don't say anything about Ripple.
Gabriel Montenegro. So, oh, thank you. I would hope we're doing this beyond Ripple, right? This is being done in Ciclo because it's supposed to be independent of Routing Pro. If you don't want to use Ripple, you don't have to. You can use something else, and hopefully
It
this
is, but we
provides some
made it
service. So
easier
it
for
cannot
us.
depend on Ripple. It's got to be self-contained.
Yes.
That's my opinion.
So,
And so
second option, yeah.
copy and paste, no reference. If somebody else wants to change, it's their onus to maybe, hey, Ciclo, would you, consider this change because it makes things better for these routing protocols? Fine, we can reconsider that. But it should be self-contained.
Okay.
Eric Nordmark, I agree it should be self-contained, but if you weren't in this room, you wouldn't know this. So you should actually capture this in the document, which says, at the time of this writing, this is the same as in Ripple. However, Ripple might change and we might not. That's what an implementer needs to know, saying that when Ripple changes, because you compare the document and say it's the same, right? And then you say, I'll use a library for that. And then someone goes and changes. Like, no, provide the information. Don't have them guess. Did you understand?
No.
Say, at the time of this writing, this algorithm is the same as in RFC, whatever.
But why?
So that people that do the diffs actually know what was discussed in this room, saying that just because Ripple changes doesn't mean that these things change.
Okay, so my second proposal was just say this is how you compare TIDs for this document. That's it. It doesn't talk anything about Ripple.
And to make the implementer's life easier, you should then make it explicitly be different. It's like saying you're using TCP sequence numbers arithmetic. Well, does that mean that if TCP were to change, does this thing change or not? You need to be explicit about what happens when change happens, as opposed to saying, well, the words are the same. If I read it, does it mean it's the same or not?
Right.
I have to guess.
That's in the draft column, the draft today.
The fact that it cites something today without being explicit what happens when change happens makes it fuzzy as well. At least it says the origin. But if you want to say, this is the origin, but they can change independently of us. That's what matters to an implementer.
I like what Eric says, because what he says doesn't change what I was asking for. What I was asking for is this be completely normative,
Yeah.
contained within itself. It could provide extra informational knowledge, like what you suggested. That's fine. That's not normative.
Correct.
I love it
It's
too.
just explaining that
Yeah, it makes-
these things are independent. They happen to have been the same at some point in time.
And it helps implementers. It's free. That's fine.
Yeah.
But it cannot be normative. That's all.
Yeah, no, it's self-contained.
So we agree with Eric. We say at the time of writing, this operation is compatible with that in RFC 6550. Okay. How much time do I have? Yes.
Well, 2 minutes.
2 minutes. Okay. So let's see. I'll have to go to IPND then, I guess. So I already discussed that the error length is now changeable. I want the working group to be very, very aware if there is any problem, because we have very short time in front of us. 6CIO is the only option to discover, the only way to discover whether we are in a backward compatible world or if we can use this spec in the full capability. Name of the unique ID is now Rover, because it's how we verify the ownership of one registration. Then Peter again gave us a very, very good and deep review, a lot of help for my French. Even after Dave, there was a lot left, so sorry for that. Yes, so I have to go to IPND because there are big changes there. So first big change is now we align to the name, obviously. It's called a rover now. As before, we have a C flag. The C flag indicates that the rover is a crypto token as specified by this specification, which allows us to basically obtain a proof of ownership of the address later. So the first come, first serve, first time you register an address, you provide the rover, whatever that is. But then later we can use that to do a cryptographic verification that you're the one who did it in the first place. And so the change in the flow is like this, right? When there is a crypto ID, and I will need my laser. So when the rover with the CD, I will be the second. Oops, obviously the laser doesn't work. So when the C bit is set, the rover is of type crypto ID, right? The length tells you if it's 64 bits or more. So if the 6LR doesn't have the crypto information, and the first time that will happen, then there is a status saying validation requested and a nonce. And basically that nonce was missing in the specs like several months ago. So it's very clear the nonce is there. And we have a router nonce, but we don't have a 6LN nonce. So if you guys think we need both nonce, maybe for some security reason we need both nonce, then please let me know, because we need to have a second nonce option. Then we actually changed a little bit the content of the second NS, because we wanted to reuse options which were present in CGI. But the problem with these options in RC 39, 31, 32 is like they were called, for instance, RSA option, and we don't do any more RSA, right? We are doing ECC, so I could not really keep the name of the option. We have to, so the proposal here is basically to use the same formats, the same codes, but kind of extend the name and the meaning of the option so that we can do other things than RSA. It's pretty much, and so the CPO is the parameter option, and the NDPSO is the NDP signature option, and they are both derived from existing options, so we are not consuming more option space. And well, that enables the 6LR basically to reconstruct the public key, because basically the crypto ID is nothing more than the hash of the public key, so as to make it shorter, right? And the NDPSO option is the public key in the clear plus a small parameter, which allows you to build more than one token with just one private key. And the result of that is signed by the public key, by the private key. So you have the public key, which validates from the token, and it's signed with the private key. You validate the signature. Okay, it's really the owner. That's how it goes. Now, this flow, as we've designed it, and that's my big question to this group. The first big question was the length. Is it okay to extend the length? And do you understand why we're doing it? So if you don't, I can explain. We need to go through that. And the second thing, oops, what was it? So let me go back to the first. We had a 64 UI64 field. We are extending the length of that field. The reason is in CGA or C3972, there were 3 bits which were actually meant to make the computation of the whole thing very intensive, because you were building SHA hashes many times, but until some bits were really were obtained with a 0, you had to update a counter and redo the hash again. So that created a huge number of hash computation till you ended up with a token of 64 bits, which had those number of bits that you wanted with the right value. That was highly compute intensive on the device. If we do that, we can live with a rover token of 64 bits, but that's highly compute intensive on the device. You can still do it, but the spec has removed that. So if you want to come back to a model like that, we have to talk on the mailing list. What we have instead now is don't do any of this complex operation. We remove the field which allows you to do that. Instead, we say, hey, if you want more security, then you put more bits in the rover. So remember, the rover is a hash of the public key. So it is. Okay. And so what was the second thing I wanted to talk about? Well, that was the strength. Okay, it escaped me. Maybe I have a slide on it. So the field I was talking about was called the modifier. So there is a huge modifier field in CGA, which allows you by incrementing to go all the way till you generate a hash which has those bits set to 0. But that's a big field. The modifier is long. We made the modifier much shorter. Why? Because if it was kept very long, it could be used as an attack against what we're doing. You have any key, and you update the modifier, you hash, till the point that you get a small rover equal to ours. So we wanted for a given key to have very few tokens that you could build out of that. We wanted to be able to build more than one token for privacy reasons. So the hash that you build is really your public address and this small field. But so you can build multiple tokens by changing this counter, this small field, but only a few of them, because otherwise an attacker could use that with a single key to brute force till he reaches the token that we have. Okay, you see the point? Question?
Mohit, a couple of disclaimers. So I don't have tons of 6-law deployment experience, and I am one of the authors of this. I think it would make sense to make it longer, but how to do it is for the group to decide. So do we just do 128 and that's it? Do we allow 128, 256, longer, shorter, something in between? Personally, I think 128 and then just live with it. But as I said, I don't have tons of deployment experience, so I don't know how that affects backwards compatibility, and if somebody wants to comment on that.
Well, there is a lot of text now in the draft about this. And the backward compatibility is not a problem with APND. That's why, I mean, it's a problem with the RFC 6775. There's a lot of discussion about that. So remember, with the 6 CIO, we discovered whether the 6 LBR and the 6 LR support this spec. And the RFC 6775 allows all the way to, I think, 256. Now, it's a matter of deployment. It's not us, right? We know already 256 is being used. Some people are talking about 512. So should we increase the length? I mean, I have put a boundary to the length, I guess to 5, something like that, which gives us 256. So you're completely right, mate. We have to check whether the boundary I gave is high enough. I mean, a recommendation could be 128. Doesn't mean we have to bar it to against longer, right? I think at least allowing 256 is seeing a future. But you could tell me go all the way to 1K. I mean, it's not hard. It's just setting the boundary to the length field. But we have to decide that. Note that it impacts the DAC exchange. Remember, the DAC has the same rover field in it. And today, since the DAR doesn't have an option, there's another consequence here. Since the DAR doesn't have an option, we don't have an option length. So the only way to infer that the DAC is the new DAC is the length of the whole message. Meaning that if we have a longer, unless we change something in the header, like a new CMP code or something, with the current CMP code, the only way to infer the size of the rover is by the size of the whole message. So we cannot add a new field and say, because the lengths have changed, you have a new field. If we say the length of the rover is derived from the length of the message, which is what we do now, the DAR DAC is really constrained in its current format. That's because it was not designed with an option. So there was no way around this. So that's why it's written that way. Okay, so think about the strengths that we need. Think about whether we can use 64 bits, meaning we have a lot of power on the device to compute the CGA the way CGA did it, or whether it's a better idea to make a rover field longer. How long? It's mostly a deployment issue. I mean, what is the upper bound that we can give today? But no, it's mostly a deployment issue. But then, is it the right way to do? I mean, that's what we have now.
For the interest of time, I
I'm
think we
done.
have
And the
to,
rest is. Oh, I could report now, maybe. So
maybe
I skip.
1 minute.
Okay, I skip the backbone router because it doesn't change. So we'll have to discuss the workgroup last call of the backbone router. There is one thing that I can mention about the backbone router is I got a feedback from implementers, and they tell me, hey, we're using that, but we're using it in a slightly different context. Because what we do, and that's kind of common in Intercloud, etc., we are using a Lisp type of operation, a resolver, so that we don't have to broadcast DNS on the backbone or whatever. It's not a backbone, but it's what serves as a backbone. They actually look up a resolver, meaning that they don't need to broadcast, and they just go unicast from the new location, the new backbone router, to the old backbone router. That makes life a lot easier on a large fabric, mostly if you do something with VXLAN or NVO3. So the result of that is you don't want a broadcast message like an NSDAD to figure out where the guy was or something if there was duplicate. What they really want is a unicast from the new location to the old location. And so they looked at our spec and they said, okay, I will do it, but I will use a Dardak exchange for unicast. And I actually think it's okay, it's a good idea, and some people are doing it. So can we code that in our spec? So, on the backbone router, if you know already where the old location was because you have a resolver or something, just go unicast, and if you go unicast, then use a Dardak exchange. Question to the room. Is it something we could document? Is there an opposition to document that?
Probably it's kind of premature. I don't know how many people have read that draft and understood the question right now. We can take it on the list.
Okay.
And so for the RFC 6775 update, we need to do some more editorial work, and then we will be
For what?
ready.
Oh, just for Eric, right? Eric's question, that's what you mean. What editorial work?
Right.
Eric's point, Dave
yeah.
and Eric, right?
Yeah.
So this will be
Yeah.
easy.
These two, and then for the APND, we need some more serious work.
APND, we need to agree on the longer thing, and we need to agree on whether, going longer is better than having those CGA type.
And whether we need to support all the use cases for Dardak.
That's backbone router.
Yeah. Oh, for the backbone.
Yes, the backbone router over the backbone using Dardak unicast as opposed to NSNA broadcast.
Okay. Yeah, I think we need more discussion.
Okay.
So guys, moment, can I just put in my usual thing here? Can we use internet terminology here? A host is called a host from coast to coast.
The meaning of leaf is a host that is attached to a REPL network. So either you say a host that is attached to a REPL network all the time, or you say a leaf.
Host.
Okay, a leaf can be.
A leaf
can be a host
REPL
or
node
can be a
that
router.
is not forwarding.
Exactly. So it's actually attached to a REPL network. So if you say host, you're losing that meaning. Now, it doesn't mean there are exceptions where a leaf is actually a router. For instance, if it doesn't know the instance ID where it's sitting on, so it doesn't know how REPL is operated there, it can still inject packets.
But then it's not a leaf, it's a router, it's a host.
So
If it speaks REPL, it's a leaf. If it doesn't speak REPL, it's a host.
Okay, sorry, Karsten and Pascal, we need to cut it off right now because we have loads of other presentations. We can discuss offline or on the mailing list.
But this term is already defined in 6550, the way I'm saying. Okay, this is yes, it is because I was presenting a role presentation for the interest of this group. That's why it's here. I think we agree at the end. So, okay, there is a new draft now at REPL, and because now we have our 6775 update and all this work that we just searched, so now we can have a real host doing only 6LoWPAN attaching to a REPL network and getting all the good benefits of REPL routing, of seamless mobility between DODAGs, etc., etc. So that means a little bit more work on the raw side. But on the 6LoWPAN side, we're all set. That's the cool news. So now this is a new draft at RAW, and we'll be discussing it tomorrow. And it explains exactly the changes we do in RAW, so that now we have the full story. And with this,
Thank you. I think we need to stop here. We are almost 15 minutes over.
So please look at the
Slides.
Please look at the slides if you're interested, or come to Roll tomorrow morning.
Thank you, Pascal.
FC 7. Oh, and my name is Yongwan Choi from Atri. Actually, I've got just quite quick presentation for this time. And this is the first, the story and status of my IPv4 NFC. Actually, I've got the 8 times of revision, and this time is the 9th revision. The version 9 is about the ND issue. Actually, there was a meeting, offline meeting with Pascal in the previous meeting in Singapore. Actually, at the time, I just almost all reflected the comment from the comment, but I just missed one thing. There was from the Pascal, the 6LN, 6LN, how to exchange their own information to each other. But I just put, for that, I just put just the last sentence. You can see, maybe not full, but the last part, they use that the LLCP in link layer NFC protocol. So they use that protocol to exchange their own information. So I just put, they want a quite quick change. So that's all, and just we have just 3 review for the working Rust code, and actually I just put this behind but maybe something.
That's it. Yeah.
Anyway, maybe you can see that the slide in your wrap up. Oh, yes. Actually, this document is in last call from March 6th, 2018. So that's all. Thank you.
Thank you.
So there were some reviews before last call, but during last call, I don't think I saw any.
There was no comment, any comment during the last call.
So if you have looked at this, if you care about this document, please send in. Doesn't have to be a deep comment. If you just think it's in reasonable shape and it should go forward, please do say that. But positive act is very, very useful.
Thank
And
you.
by the way, working with last call is over on Monday, right? But please still go ahead and send your positive acts or more, but at least positive acts would be very good to hear. Thank you.
Thank you.
Hello, I'm Charlie Perkins from Huawei, and I'm here to tell you about recent update for the deadline time document. How's that? Okay. All right. So I'm Charlie Perkins, and I'm here to tell you about the deadline time routing header. This document has gotten pretty good comments for the last previous IETFs, and I think we've made good progress on it. Basically, what it does is it allows you to tell what the deadline time is for packet delivery, and if the packet is not delivered in time to meet the deadline, then you can drop it. You can also include the origination time so that devices along the path, the routing path, can determine how long the packet's actually been going. And this enables you to do some scheduling decisions. For instance, if you see a packet that's, just as an example, if you receive a packet that's sort of getting close to the deadline, maybe you will allow it to be routed in preference to other things that have less urgent delivery deadline. It's assumed that the networks, the devices that are looking at this header are in time synchronized networks, otherwise they can't really know what the deadline time actually means. And then there's a simple mechanism for allowing you to make sense of the deadline time, even if you cross over time zone boundary. So draft's been around for more than a year, and we presented it and got some good comments, and included the origination time, made a sort of compression mechanism for representing the time in the header. And then we, for the next revisions, we included the slot number as a time unit, and made some slight improvements in the header compression. All along, there's been implementation, and that's available for OpenWSN. And you can look on GitHub, and you look in the presentation materials for the URL. I wouldn't expect you to want to read those. So then after all that, the draft was adopted as a working group document. There was a lot of interest. And now we have our last update is actually quite minor updates. We read through it and fixed a few little editorial things. It was requested that we put in some information about how the time synchronization can be achieved between the networks. And it's not, I think it's clearly out of scope for this document to make a normative requirement for that, but we did borrow language from another draft that had a similar similar goal, and we just put in the time synchronization mechanisms that were appropriate, or at least feasible. And there was in the previous draft reference to the OAM, which has then, in the meantime, been adopted as a working group document in IPPM. So it was, we should cite the working group document. And this is not normative. And also, the most substantive change was to modify the meaning of the drop flag from should to must. So actually, I still think it's a little bit in the middle somewhere, like strongly should. But anyway, it's now says must. And the last thing we did was, according to a comment received on the mailing list, is to describe what kind of delays are observable in the network. And this is purely informative. And I don't, well, anyway, as far as I know, the draft was already pretty close before we made these changes, and now it's extremely close. So I'd like to request any comments or suggestions about the draft. Just to briefly review here, the changes you can see, as there's the must is in red, and there's a slot, I mean, there's a time unit for the network slot number. And then other than that, oh, one thing about this could be slightly misleading, and that is that the fields for the delay time and origination time, which are called DT and OT, they are not mandated to be 16 bits. They can be optional length. And according to, let's see, do I get a pointer here? So according to the values that are specified in the delay time length and the origination time length, that determines the length of these fields. So that's it. I think document's ready. appreciate more review and consideration. And if you agree that the document's pretty much ready, we'd like to request a working group last call. Is this one you want to see? Okay. That's it. Thank you very much.
This is the one we had.
Good afternoon, ladies and gentlemen. My name is Yonggun Hong, working for IETF. So this is the presentation of update 6-row applicability and use case draft. Okay, this is the history of this draft. So this time is the first revision. So I would like to emphasize the goal of this document. The goal of this document is to help 6-row pen stack adaptation by L2 constraint technology and help a newcomer understand how 6-row pen stack can be applicable in practice. So we want to, this draft could be useful for new adopter of IoT at IETF.
Pascal here, do you mean adoption here? I'm trying to figure out. Help 6-low pen stack adoption? No?
Adaptation.
Adaptation.
Yes.
Adapt over.
Yeah. So after the update since the last meeting, so we add two practical 6-row deployment scenario. One is G3 PLC usage, and another is netlist usage. And we update MSTP part. So thanks to the Caroline and Deb Robin, so they help to update the MSTP part. And we add the 6-row Bluetooth mesh draft in this document, and we made some editorial update. So in this draft, we have 7 specified link layer technology: G-Wave, BLE, DAC BLE, MSTP, and NFC, PLC, and IEEE.15.echo, and we have potential candidate, that is the LTMTC. So I consulted and checked that one of the author of this draft, Dong Young Go, he is working for SK Telecom in South Korea, the largest #1 mobile operator. So they have a plan to deploy IPv6 on LT and LTMTC, but unfortunately, in this case, the 6-row adaptation layer is not needed because the LTMTC can provide transmission IPv6 without the help of the 6-row technology. So I want to remove in next revision. So this is the current status of the regarding LTMTC cases. So if I was wrong, so if there are some missing, then let us know. Then we can check once again the case of LTMTC. So it's the comparison across the 6-row link layer technology. The red part is the update part. So the MSTP uses, we modify the building automation, and the BLE MSTP, their technology and subnet was changed like this. So in this draft, we have the guideline for adopting IPv6, so you can check that. Yes, I think that the most important part in this draft is to 6-row deployment scenarios. So in this 6-row working group, we are talking about 6-row technology, but more interesting is there any real world to adopt 6-row technology. So until now, we found the 4 areas. One is Jupyter Mesh and Wyson, G3 PLC, and Netricity. So Wyson is also described in the last revision. So on the behalf of the Wyson Alliance, Paul Duffy helped to prepare this text. And also Jupyter Mesh, we have a text by the help of the Michael Bellinity and Das Subier to provide this text. Okay, so in this revision, we add G3 PLC. G3 PLC is narrowband PLC technology. So now it supports IPv6 and IP 6-row adaptation layer. So Jinkun Hui at Huawei to have to prepare this text. Also, Netricity program in HomePlug Powerline Alliance, they also have some deployment scenario based on the 6-row stack. This text also come from the Jinkun Hui at Huawei. So this is the design space dimension. You can see there are some couple of the design space dimension. Okay, so in the appendix section, we have a couple of the 6-row use cases. So each of the 6-row technology. So we update use case of MSTP. In this revision, we describe the building automation network based on MSTP technology. So as I said to Caroline and David Lavin to update to this part. So thanks to. And the other is the same as the previous version. So that's all. So I think that this draft is a kind of the stable version. So, but we want to gather or collect the useful information to deploy 6-row technology in the real world. So if you have some deployment scenario in the real world, so let us know so we can add or update this draft. So that's all.
Gabriel Montenegro. So I like what you're saying about removing something that is not really related to stuff we've done here in 6-row working group, this LTE thing. So we have no document that points that like the work we've done here to adapt that. So we should delete it definitely. Along those lines, Netricity, I couldn't grasp very well what document that we have done here or that we have adopted points at what the adaptation for Netricity.
So one is the NFC. NFC is not the 09 version. So we have the PLC document. PLC is also the individual draft.
So so the NFC Netricity is NFC?
Oh, no, it is the PLC technology.
PLC. Oh,
yeah.
the one that is not yet adopted.
Yeah,
That's Netricity.
Yeah.
Okay, but we're discussing it here, and okay, got it.
Yeah.
Understood. Yeah, I think the criteria in general should be if we're doing work here, then okay, sure we can write. Otherwise,
so,
it doesn't.
Yeah, if you see the comparison table,
Okay.
we add the reference document. So
Yes.
among them, the PLC is individual draft. So we
Yeah.
have some consideration.
But it's progressing, and arguably this document will help them to know what they need to do to get it to be adoptable. So yeah,
Okay.
that's reasonable.
Okay.
But yeah, if we don't have a document down there, then we shouldn't have a column for it.
Okay.
Okay, thanks.
Okay, thank you.
Hi, Bob Hiley, Wyson Alliance. Just a point of information, Netricity is now part of Wyson.
Yes, I
Yeah,
heard that.
so I just noticed that in there. You may
So,
want to.
I want to say that I heard that so it will transfer to Wyson in future.
Yeah.
So it is not official announcement. So I don't say that. Yes,
Okay.
you are right. Thank you. Okay, thank you.
Okay, so next is design team.
Can I use the clicker? Okay, good afternoon. My name is Thomas Oteina. I'm chairing the 6-flow fragmentation design team that we created a couple of months ago, and together with at the last IETF. Yeah, I have a slide on that. So there are 6 of us looking at what we believe is a rather old problem, which is fragment forwarding, and we believe that we have some elegant way of dealing with it. So this is the context. So pre-IETF 99, fragmentation has been brought up a number of times in these meetings, and so we decided to look at it. And so the 6-flow chairs asked us at IETF 99 to ask for volunteers to create a design team. The design team met for the first time at IETF 100 in Singapore. We formally created the design team, and so here we are 4 months later to present a number of things. I'm going to present problem statement and goals. It will take me about 10 minutes. Karsten will then present a draft on minimal, an implementation technique to do fragment forwarding without changing anything to the protocols. It's a kind of elegant thing. And then Pascal will present fragment forwarding. Now, I need to say that we have been discussing this quite a bit for the last couple of days. This has already been presented at LWIG. So some of these slides are a little bit outdated, and some of these slides you might have seen already. But we wanted to do a full report during these 40 minutes that we have now. So this is the goal of the 30 next minutes. I'm going to start by giving a overview of what the problem is and what the goals are, and I'll hand it over to Karsten to talk about the implementation technique. I think that so as a design team, we have something to report to 6-flow. I think we will leave it to the end to talk about the future of the design team and how we move on from now on. But we have a very clear idea, and we've already discussed it kind of privately with the chairs.
Just one correction. We have 30 minutes.
30 minutes.
Yeah.
Sounds good. That should be good. So problem statement. We have had fragmentation part of RFC 4944 and 6282 for a while. And so the naive way of implementing it is doing per hop reassembly, and I'll show you that has some problems. There are some candidate solutions that will do fragment forwarding, including Karsten's book, and Karsten renamed it to Zach's and Karsten's book. So I'll correct this orally. And then Pascal has had this draft for fragment forwarding that also provides a piece of the answer to that problem. And I'll finish these 3 or 4 slides by the goals of the design team so that everybody's up to speed. So in 4944, what is defined as a link layer fragmentation technique, which is used in route over, which allows you to reassemble at every hop. That means that the packet that's too long is fragmented to many little pieces. These little pieces are sent to the next hop. And at the next hop, you reassemble them in a reassembly buffer. And then you either have reassembled it completely, form a new IPv6 packet, and then forward that further on, or you weren't able to reassemble everything, and there's some timeout that will cause that reassembly buffer to be dropped. So the naive way of implementing this is to do a per hop reassembly. That is, at one hop I fragment it, I send it to my neighbor reassembles everything, refragments it, sends it to its neighbor, etc., etc. This has not changed in RFC 6282. There's one sentence about reassembly. It says basically 6282 does not touch the fragmentation part of 4944. So the problems are that if you do per hop fragmentation and reassembly, you have 2 major issues. The first one is latency. You have to wait for the last fragment wait to receive the last fragment before you can start sending the first fragment out to your next hop. The second problem is probably the biggest one. That is a problem with reliability, because you need those huge buffers to do reassembly in. If you're reassembling one packet and you receive a fragment from a second packet, it is very possible that you run out of RAM memory, especially on these little constrained devices. And so you have no other option but to drop that packet. And so your network that you've been building with so much love kind of don't deliver any type of reliability, and so everything goes bad. So we want to solve that. So the proposed solution is to do fragment forwarding. Fragment forwarding means I have a fragment that goes from A to B. Well, B, instead of having it in the buffer and waiting for the whole packet to reassemble, it will forward that fragment immediately. So if I'm sending data from a node into a mesh onto the internet, for example, the source node will fragment the packets, will send it to the next hop that will immediately forward it, and it's only at the LPR, the egress point of your network, that you do the full reassembly before sending that as a, of course, purely valid IPv6 packet onto the internet. So there have been a couple of example solutions. There's this paragraph here in Zach's and Karsten's book that shows you one implementation technique. I won't read this because that's actually the purpose of the next slides, is to kind of write out how this works. Another solutions draft was the forwarding fragment draft by Pascal, which not only does fragment forwarding, but also adds on top of that fragment recovery, meaning if I'm a source node, I can ask the destination node how many of my fragments it had received, and then the destination node can then tell me, hey, I'm missing fragment 3 and 5, and you resend it. So the goals of the design team. So that's kind of the context of where we were beginning of the Singapore meeting. The context of the design team is to produce 2 documents within the 6-law working group. One is an informal document which summarizes the fragmentation and kind of critiques what is going on right now and what the problem statement is. The second bullet point we have, this is where, when I told you the slides were a little bit outdated, we have discussed this with Carsten and with 6-law chairs to produce that second bullet point, to have it be its own standalone document that is progressing in the LWIG working group, which is the technical description of the virtual reassembly buffer. But the informational 6-law document will still discuss its limits and how kind of that fits with everything. The second 6-law document is a standards track document, which looks very much like Pascal's fragment forwarding draft, which defines a new protocol that does, among other things, fragment recovery, which the implementation technique does not do. Okay, so the philosophy of the design team is to move fast, close it as fast as we can. Let's discuss a little bit later where we think we are. And that's, I think, the end of my slides. Carsten, do you want me to run through these? Do you want to present these?
So I did the full presentation in LWIG yesterday. I don't really want to repeat that. Who was there yesterday? Okay, good. So in the minimal fragment document, there are a few sections about the context and the virtual reassembly buffer technique. The funny thing is that I submitted my draft, my personal draft on how to do this about 24 hours before Thomas did. So we now have 2 drafts with essentially the same information. Just to remind you, what happens normally in a reassembly buffer is you reassemble all the fragments you get, and only when you have all of them, you actually forward the packet, which means you then burst out those fragments. And that has a few problems, as Thomas noted. And the ideas with the virtual reassembly buffer is simply to implement a reassembly buffer, but to not actually store the data any longer than you absolutely have to. And normally, this means that as soon as a fragment comes in, you can actually forward the equivalent fragment of the new packet you would have sent out by changing the header in the first fragment and just copying out the fragment in the rest of the cases. The only thing you have to do is the thing you would have done with a real reassembly buffer as well. Of course, you need to remember under which datagram tag you are sending out the fragments on the outgoing link. So on the incoming link, you got the datagram tag assigned by the previous hop, and you have to manage your own datagram tags because that datagram tag might have been taken that you actually get there. So you essentially just have a table that pairs source and destination addresses and datagram tags, and that's all you need to store. So that's really very little information. And the nice thing is you can have many, many more of these virtual reassembly buffers than the big real ones. Now, what I said is not entirely true, because to forward a fragment, you actually need media access. And of course, if the media access is under contention, you may be in a situation where you get more fragments in that you actually can get rid of. So you still need to have some buffer space, of course, but this is buffer space that is measured in fragments and not in entire packet buffers that you need to have reserved, but that are unused most of the time. Things, apart from what I just said, things you have to consider is you might have to wait for more than one fragment if the first fragment doesn't contain all the information you need to make the layer 3 forwarding decision. For instance, if you have a giant source routing table, that is not going to work. Out of order fragments are a problem, of course. One question that would be really interesting to see is, do we actually have them in real world networks? And a little piece of complication is that the incoming fragment and the outgoing fragment can actually have different header compression efficiencies. So you might get a 127 byte fragment in, and might have to send a 129 byte fragment out, which you can't. Since all the header compression stuff happens in the first fragment, the recommendation is to just put the slack into the first fragment. So instead of fragmenting 128, 128, 50, you fragment 50, 128, 128. So if the 50 turns into 54, that's not a problem. You don't have to, the forwarder doesn't have to create a new fragment. The DOS-attack situation is essentially the same as with real reassembly buffers, except that the resources consumed by a reassembly buffer are much smaller now, so it's somewhat mitigated. But of course, somebody who really wants to overload, you can still send you tons of first fragments. There is no fragment recovery in this technique. It's just an implementation technique. And also, just as with real reassembly buffers, you have to send out all the fragments on the same link. So you cannot do per fragment routing. And as soon as you need one of these things, you actually need more protocol. So you cannot just use 4944 and implement it this way. You need additional protocol. I just looked it up. Pascal submitted the grandfather of Draft-Tuber 6-law fragment recovery on February 6th, 2008. 8. Yeah, happy anniversary. Okay.
I'm Yasuki Tanaka from INRIA. So this shows the Boolean simulation result. I implemented both RC4944 reassembly fragmentation mechanism and also the draft pattern, so the minimum fragment. So that's what the cutscene now explained. So maybe you know the idea is, so blue line is a fragment forwarding that's using the VRV table. So that's consume much less memory compared to the 4944. So that the x-axis, it's a number of fragments per packet. So one fragment per packet means no fragmentation. So that's why the graph starts the 100%. So then, I'd like to add several things which are not covered in the slide. So on left side, there's the topology that is used in the simulation. So link PDR at 100%, there's no packet frame loss. And also, I said a TX buffer in each mode is large enough. That means there's no frame loss due to the TX buffer overflow. And also the sync node, it's the top of the root node have no memory limitation to try to understand what happened in the intermediate node. So yeah, so that's a very preliminary result, and I'm around there. So please contact me if you want to know more details. Thanks.
Thank you.
Thank you, Yach. Yeah, you can run this yourself if you want at this address.
Actually, I want to ask one quick question. Maybe
Please.
I should go to the mic. Or I can ask from here. So did you analyze something that in what kind of situations, like the number of hops, the bytes sent, in which cases we can use the minimal fragment type of solution, and the other case we will go for the full-blown?
Yeah, so this slide here is to illustrate the usefulness of minimal fragment compared to 4944. It does not attempt to compare minimal forwarding compared to fragment recovery that Pascal is going to present at all. We haven't done this at all. The only thing this shows is that even if the links between the nodes are perfect, the packet delivery ratio is 100%, you're still losing a lot of packets because of the lack of RAM memory in node 1 here. And so this one, basically node 1 gets a fragment from node 2, starts reassembling, then it gets a fragment from node 6 and drops that because there's not enough space. And so what you see here is, if you had an infinite memory, everything would be perfect. Whether you do fragment forwarding or not, it would be perfect. But as soon as you introduce the limitation of memory, which is very real, you lose data. So we have results with 1 reassembly buffer, 2 reassembly buffers, 3 reassembly buffers. It gets a little bit better, but you never get to 100% the way the minimal fragment. Plus, you see the difference on RAM. There's about a 5x factor of RAM memory. I mean, there's no question. This is just working better. It's an implementation technique that everybody should use. Of course, this slide and this work does not at all compare the limits of minimal fragment with fragment recovery. So just playing with minimal fragment, what we're working on is more bigger scenarios with real traces to see like large deployments that we know that we master these kind of things, kind of going beyond the simple canonical case that you see on the left here to something more real. But we don't expect the results to be very different. I mean, we'll just provide some fancier numbers, but it will be the same base message. We haven't thought about comparing the two approaches yet. It will happen at some point. So one point of clarification, and probably this slide here is wrong. But we had this big, because we had a desynchronization of 1 day between our different drafts. What we will do is have 2 6-low. I mean, what the plan is to have 2 6-low documents and 1 LWIG document. The first 6-low document explains the context and the limits of the different implementation techniques. The LWIG document contains the actual very short description of the implementation technique itself. And then the second 6-low document is Pascal's draft about fragment recovery. Fragment recovery. So that's the plan. Which leads me to Pascal's slide.
In the meanwhile, I'm just looking for the blue sheets. Where are the blue sheets? Everybody signed them?
So in interest of time, because we don't have it, I won't go through any details about what this draft does, but just what the update is. The main update is the title has changed because the draft was doing 2 things. It was doing fragment forwarding and it was doing fragment recovery. And over the 10 years history of this draft that Kirsten has been talking about, the name has changed back and forth between insisting on the recovery side and the forwarding side. And I never knew which one to pick up for the title. But now this is finally resolved because I just took out of the draft the description of the forwarding because now it's in Kirsten's draft. So that makes my life simpler about finding a title to it. That also makes my life simpler about explaining how the forwarding works, because Karsten is giving a lot more and better details on this. So basically, the main diff between this draft 00 and the fragment forwarding 08 that was in the original agenda is that the details of the MPLS operation using the datagram tag are gone, right? But that did not actually take out a lot of the draft. That was a small piece. It was a very important piece, obviously, but it was small. Now we insist on the fact that because we are doing the acknowledgement back, we not only have one LSP from the source to destination, but as we are forming this path, we are also forming the return path from the destination to the source, which enables us to send the acknowledgement. So conceptually, if you, and that's to be synchronized with Karsten, but if you see that the VRB has as part of this constituent a label switch path, then for my draft, I need two of them. So it would be better, and I don't know how we'll synchronize with Karsten, but that the draft actually, the Karsten's draft shows the VRB as a buffer, but also an LSP. And so I can say, okay, now I'm doing same, but I have a second LSP for the way back. Okay, that's what I intend to do. The other thing is, because the description of the street draft was not exactly clear at the time of the publication of this draft, I'm pointing on draft Vatini for the forwarding, and I will have to change that to point on draft Karsten, right? And that's how it's going to work. Otherwise, I mean, you know, like Karsten said, the operation there, it's been there for a while. So if you want at the next session, I can go into more details about how the acknowledgement works, etc. But we don't have time today, so let me just show you the difference between what we do here and the value of changing, of having the new standard track format. Is first, we can do selective recovery of individual fragments. We have a bitmap, pretty much like we do in LP1. And the bitmap expresses the individual fragments. So the acknowledgement back all the way will tell which fragments were lost. It's not the only problem that we solve. If you remember the presentation I made several IETFs ago, I listed like 5 or 6 problems, and forwarding and the size of buffers were 1 or 2 of those problems. But some of them were due to the sequential sending of multiple fragments, which could interfere with one another. And even if you have virtual buffers, if you push too many buffers too fast, like Karsten said, into a device, you may still override the number of buffers that it has. Since the TCP days, we know that the optimal number of things that you can put on the network is at most 1 per hop. So the idea is, how can we control the number of fragments, and how can we pace the fragments that we send over the networks, so we don't eat the condition of congestion inside the network. So there is some congestion control here. So this goes beyond, this benefits from everything that Thomas said, but this goes beyond into protecting the network and preventing the loss of individual fragments. Even if fragments are lost, then we can retry them. Finally, since we have end-to-end signaling now, because we have an LSP on both directions, we can explicitly notify the source and every hop that there is an abort condition or that the flow is complete. This is kind of interesting because you know when you can clean your VRB. Okay.
Okay. No, not today. Thank you. So thanks to the design team. I think we have good answers for some of the, well, at least the initial questions that we set out to resolve. At this point, the question for the design team is: are you okay with the direction you're giving the work and the draft that you were giving to the working group? Is there anything else you would like to still attack before dissolving? Thomas?
Yeah, I see Karsten standing up. I wanted to wrap up, but if you have any comments, please raise them now.
No, I just wanted to remind people that, of course, the normal working group process now starts. So we need comments on these three.
Yeah.
The 3 documents are not done. They are not intended to go to working group last call next
Yeah,
week.
Absolutely, no, but the point of the design team was to start something
Yes.
that would then go back to the working
Yeah.
group. So
Just wanted
we
to make
know-
this crystal clear.
we know of 3 documents that will now come into the regular working process. Is the design team done?
So-
Or
Yeah, so that's exactly the point I was going to make. I mean, in the end, these are work group documents. They're not design team documents. So I think we're done once those 3 documents have entered the pipeline within the different working groups. I'm actually asking for your advice. If we were in 2 documents, I think we should close the design team right now. Since we're talking about now 3 documents, 1 LWIG, 2 6LO, I think there's a little bit of editorial work to be done on the first 6LO document. So I would feel more comfortable if you agree to not close the design team right now. Just let us do this for a couple of weeks, and then once it's in the pipelines, we just close the design team.
Yeah, I think that makes sense, because we know in theory there's going to be 3, but we don't have them today.
You don't have them. Yeah.
So until we have them, there's probably some good
Yeah.
grounds to continue synchronizing and meeting or discussing.
Yeah. Now,
that makes sense.
Yeah.
Until we see them appear.
Yeah.
Then
Yeah. So I should notice I don't. Should we wait for work group adoption before closing the design team, or is this orthogonal? I don't know. It's orthogonal.
I think it goes into the design team output is like an individual's
Okay.
output.
Okay,
So
so there's-
the individual would go into the working group process,
Yeah.
and eventually it would get hopefully adopted.
Okay, so there's no requirement of that.
No, I think like Suresh Krishnan. So I think these are like orthogonal. You can keep it going on if you want. Like you can keep on like for the MIF design team, like we had the stuff going in parallel, right? But everything still goes through working group consensus. So we had a call like once every 2 weeks or whatever. It's just to make sure that like anything coming in the working group process is funneled in and the results are funneled back, right?
Yeah.
So like, it's like a bunch of people going together and doing something, right? Like we cannot stop it or like tell them not to meet, right? So that's, I'm personally fine just letting,
Okay, so then
keeping them independent. That's it.
Okay, thank you. So in that case, I mean, we'll deliver the 3 documents. Let's close it afterwards. Let's not leave it open for no reason. Thank you.
Going once. Yeah.
Thank you.
Sold.
We have now last comment from our informational, just a few words from Benjamin.
Thanks for giving me some time to talk. So I'm Benjamin Tertoro. I work for Carival. We worked on the IFENTEROP platform to implement interoperability tests for this platform. So we provide some test specifications from the current RFCs of 6LoWPAN for neighbor discoveries, header completions, and also some tests without header completions. So you can, we'll communicate to you through the mailing list, the more information from how to access to the platform, and how to perform the test, and etc. for you to be able to use this platform, and while using this platform, giving us feedback on how to integrate more things and how to improve this platform. Also, we will also organize a 6LoWPAN plug test in the next 6 months to come. So we will send you more information about the date and the place. So for those who don't know, I will explain a bit what IFENTEROP platform is. The goal is to provide interoperability testing through the cloud. So you have one device in one place, and another device in another distant place, and through the internet, through a secure channel, you will be able to send those packets and make a bit of conformity, or transmit those packets to the other device and see if the device are able to communicate or not. And the goal is to reduce the cost of doing interoperability tests. So if you have some questions or some comments to make, you can, or we can talk after if you have some implementations to share, to try and test the platform a bit more, because we only use the 6LoWPAN implementation on Linux, on Raspbian, to test the platform. So it could be good for us to have another other implementation if you have some. Any comments?
So Thomas Otena, the physical layer that you're addressing, are you?
Yeah,
is
I
it-
didn't say,
Yeah.
It's only 802.15.4.
Okay,
And we intend in near future to add a more physical layer.
okay. Because you said something about some Linux implementations.
Yeah, we use the Linux and WPAN tool on Raspbian to perform the test and to test the platform.
I see. But then there's a 15.4 dongle on your Raspberry Pi that allows you to actually generate.
We plugged the NatMail card on the GPIO of the Raspberry.
Okay, so 6LoWPAN on
On
15.4.
Raspberry, yeah.
Okay, perfect.
I think it's good. Thanks for your
Thank
attention.
you. And maybe next time you start the process early so people are aware and make plans. Thank you. Yeah, so is there any other issues or questions? Otherwise, we are done for this time. Thank you very much. See you next time.